In section 5.2, we focus in on the uniform distribution. And when we look at the uniform distribution, this is a continuous probability distribution where all the events are equally likely to occur. And it's represented by the notation X, and then you've got this little squiggly symbol there, and then you've got U standing for uniform distribution, and then from A to B means A is the lowest value in that distribution, and B is going to be the upper value in that distribution. So we want to remember, and we learned about this quite a while ago, the uniform distribution when we were dealing with the bar graphs is the one that they all look pretty much equal. Well, here in our continuous probability distribution, they will all be exactly equal. The probability density function, in other words, the value of this function, is given by the notation f of x equals 1 divided by b minus a. So b minus a, remember, are the endpoints of your distribution. And then we do 1 divided by b minus a because we know the entire area underneath our curves for these probability distributions have to be 1. So it's going to be 1 divided by b minus a. The theoretical mean of the probability distribution, probability density function is given by mu equals a plus b, so those two endpoints, you add them together, and then divided by 2. Our theoretical standard deviation for the probability density function is given by this equation, sigma equals the square root of a plus b squared, again using those two endpoints, so a plus b squared, and then divide by 12. And then after you do that inside part, then you take the square root of that whole fraction. Recall that the area, when we're looking at any sort of a function, is base times height, and because this is a constant function, the probability density function here is a constant. It's going to be horizontal, which means all of our shapes are going to be rectangles. Example 5.6. The data that follow are the number of passengers on 35 different charter fishing boats. The mean, the sample mean, 7.9, and the sample standard deviation is 4.33. The data follow a uniform distribution where all the values between and including 0 and 14 are equally likely. State the values of A and B, write the distribution in the proper notation given there, and then calculate the theoretical mean and the theoretical standard deviation. And then the sample data is shown on our note page. So here is the situation. To write it out, we're going to have x, and then we've got our u, and then a is the lower boundary, which is 0, and b is the upper boundary, that is 14. So that's the first thing we would do to write it in standard form, proper notation. The theoretical mean, remember that the theoretical mean is going to be a plus b divided by 2. So, and I don't remember if they did it which order, but it doesn't matter. We're adding them together. We divide by 2, and we would get 7. And then the theoretical standard deviation is the square root of a plus b squared divided by 12. Now I'm going to pull up the calculator just to show you exactly how we would do that on the calculator. So on the calculator, you're going to type in your square root button, second squared, and then you're going to put in your parentheses, a plus b, 0 plus 14, close your parentheses, and then square that, and then you'll put in divided by 12. And that's how you would type that in, and we get an answer of 4.04. Let's go back to our screen and compare. So we do get a mean of 7 and a standard deviation of 4.04. And notice those are relatively close to our sample mean and our sample standard deviation. The sample mean and sample standard deviation are slightly higher. So when we compare them to the sample statistics, they are off a little bit. The sample has a slightly higher x value for the mean and a slightly higher standard deviation variability there. Example 5.7, the probability density of a random variable x is given in the figure below. From this density, what is the probability that x is greater than 1.38 or x is less than 0.26. So what we want to do first of all is figure out the value of our function. So f of x will equal 1 divided by b minus a. And b in this case is 2, where it ends, and a is 0, where it starts. So 2 minus 0. And so we know our value of this function is 1/2. So we can put that in right here. We know that that's going to equal 1/2. Then we want to mark off these areas. So 0.26 is going to be about right here. The picture isn't terribly important, but we want to get an idea of what we're looking for. So that's 0.26 is the boundary for the first one. We want things less than that. We also want greater than 1.38, which we'll say that's about right here, 1.38, and we're looking for greater than that. Okay. So looking at that, we're going to find the area of each of these. So let's consider this area 1 and this one area 2. So to find the area for that first section, we're going to take the base, which is the width of that is 0.26 minus 0, because those are the two endpoints here. The 0.26 and the 0 are the two endpoints for that one. So we'll subtract those and multiply by the height, 1/2. And then for area 2, we'll do the same thing. The higher boundary value is 2. The lower one is 1.38. That gives us the total width of that area. So 2 minus 1.38. That's the length of the base times the height, which is 1/2. That's the value of our function. And we're just looking at each of those rectangles. So I'm just going to do this one. You just type it in exactly as you would. So parentheses 0.26 minus 0, close your parentheses, times 1/2. That first area is going to be 0.13. The second one, 2 minus 1.38, and put your parentheses in there, times 1/2, and we're going to get 0.31. So to find the probability that x is greater than 1.38 or x is less than 0.26, we would add these two together and we would get 0.44. And that is our probability of a random value being in either of those two areas. Example 5.8. Suppose that the value of a stock varies each day from $8.82 to $21.17 with a uniform distribution. Find the third quartile, which means 75% of all days the stock is below what value. All right, round your answer to the nearest cent. So what we have to do first is we want to draw our uniform distribution. Doesn't matter how high it is really at this point. But we know the lower boundary is 8.82. The upper boundary is 21.17. So our first step again is to find the value of f of x. So f of x will be 1 over, and then we take the upper boundary, 21.17, minus the lower boundary, 8.82. And let's go ahead and do that on the calculator. Again, when you do that, if you're gonna do it all at once, you're gonna want to put parentheses around this. So 1 divided by parentheses 21.17 minus 8.82, and we get kind of a messy number, but we'll round it off to, let's see, we're gonna round, since our final answer is gonna be 2 decimal places, we're gonna go ahead and round off to 4 here in the midst of the problem. So 0.08, and then when we round this off, 0.97, it's going to round off to 10. So that's going to be our estimated function. We're rounding that off, our approximate function, 0.0810. Okay, then we want to find the value where 75% of the days are less than this. So this one's a little bit different because usually we know the value and we're trying to find the probability. This time we know the probability is 0.75 because that means 75% of all the days the stock is below this certain value. And we know in order to find that, we're going to take the value 0. Well, let me do this. The area of the base, which will be x minus 8.82. That way we're doing everything in the same order each time, times the height, which is the 0.0810. And probably just algebra here, what I would probably do is rather than distributing, I think it'll be easier to divide by the 0.0810. And I'm going to go ahead and do that. So 0.75 divided by 0.0810. And you could actually just use the answer button and not round off at all. In fact, I'm going to do that. So let me go back. 0.75 divided by, and I'm going to use my answer from before. And I'm going to get, it may still be the same, but this one actually comes out exactly 9.2625 equals, and then we're going to have x minus 8.82, and then we're going to add the 8.82 to both sides. Again, just algebra. And when we add that, this will cancel. We'll just have x, and then on this side, we're going to have plus 8.82. We get 18.0825. And we are told we're supposed to round that off to the nearest cent. So this would be the nearest cent, that 8. It's going to stay exactly where it is. So we're going to get x equals 18.08. Okay, now just to double check, because I'm kind of curious, if I had done the 0.75 divided by 0.0810 and then added the 8.82, when we round, we still get the exact same answer. So our carrying twice as many decimal places works out fine for that. So 18.08 would be our value for the third quartile. Example 5.9, the lengths of a professor's classes have continuous uniform distribution between 49.2 minutes and 55.5 minutes. We randomly select one class and find the probability for the class to run longer than C number of minutes is 52.9%. In other words, the probability of X being greater than C is 0.529. Just converting this percentage into a decimal. That's all that was done there, and writing it in probability format. Find the length of the randomly selected class. In other words, find C. So once again, we've got to set up our picture here. We know that it's a uniform distribution between 49.2 minutes and 55.5 minutes. And once again, we need to find the value of the function. So f of x will equal 1 divided by, and then we find these endpoints, 55.5 minus 49.2. And I'm going to make sure I put parentheses around that when I type it into my calculator. So 1 divided by parentheses 55.5 minus 49.2. And that gives us, again, a bunch of numbers here. Let's see, we're supposed to find the number of minutes. So they give their answer in tenths. We're going to go ahead and go to the nearest hundredth, even though tenths probably makes the most sense. But that way we'll keep some extra decimal places in the midst of this process. But if we keep our 4 decimal places, we're going to get 0.1587. So that is our value of this function, 0.1587. And again, drawing the picture, this time we're looking for our C, our X value to be greater than something, some length of C. So this is the area that we're looking for this time. And when we do that, we're just going to set up our value again. We know that the probability of something being in that area, They gave it to us. It was 0.529, so we're going to use that. We already know the probability is 0.529. That equals the width of the base, the length of the base, which is the larger value, 55.5 minus C. We don't know what the smaller value is. And then times this 0.1587. We're going to divide again by the 0.1587. Whoops. 0.1587. And we will divide that. I'm again going to use my answer button because if you remember back at the beginning, if we had to round, we round to twice as many decimal places, but if we don't have to, which in this case we don't, we can just use our answer button. So 0.529 divided by our answer, and that's going to give us 3.3327. That equals 55.5 minus C. We're going to subtract the 55.5 to cancel. So minus 55.5, and that gives us, moving this over here so we can see it a little better, negative 52.1673 is equal to negative C. Well, algebraically, we're going to divide by -1, which means we're just going to change both of these signs. So we get C is 52.1673. Again, I would say rounding to the nearest tenth of a minute is going to be good because that's what our original values were given in. We're not finding a mean or anything like that. We're just finding a number of minutes. So 52.2 minutes would be our length of time, where about 53% of the classes run longer than that. That is the end of section 5.2. So you can go ahead and work on those 8 graded problems. Again, if you get stuck, please make sure that you reach out and contact me, and I will try and answer any questions that you have.